Two of humanity's favorite beverages, coffee and wine, trace their origins to fermented fruit. From highland coffee cherries to vineyard grapes, this episode weaves the stories of microbes, temperature, and time that turn fruit into liquid ritual. In equatorial coffee orchards, pickers strip or selectively pluck ripe cherries. Wet processed coffee cherries are pulped. Beans ferment in tanks to dissolve mucilage before being washed and dried on patios or raised beds. In vineyards, grapes are harvested by hand for quality or by machine for efficiency. With decisions influenced by sugar, degrees Brix, acidity, and tannin maturity. After harvest, red grapes are destemmed and crushed, leaving skins for color and tannins. White grapes are pressed immediately to avoid bitterness. Coffee beans rest during drying, but in wine, yeast springs into action. Natural or cultured yeasts feed on grape sugars, producing alcohol, carbon dioxide, and heat. Fermentation temperature shapes flavor. 22 to 25 degrees C for reds to extract tannins, 15 to 18 degrees C for whites to preserve fruity aromas. In coffee roasting, heat triggers similar transformations. At 196 degrees C, beans undergo first crack as moisture escapes. At 224 degrees C, second crack breaks down cellulose and oils emerge, turning beans from green to brown and releasing aromatic compounds. Some wines undergo malolactic fermentation, where lactobacter convert tart malic acid into softer lactic acid, smoothing the palate. Pressing separates wine from skins. Aging in oak or stainless steel allows flavors to integrate. Lees settle. Tartrates precipitate during cold stabilization. Meanwhile, roasted coffee beans are cooled rapidly to lock in volatile aromas, then rested for several days as carbon dioxide escapes and flavors balance. Before reaching your cup or glass, both beverages undergo extraction. Winemakers rack, blend, and fine the wine before bottling. Coffee roasters grind beans to specific sizes. Water temperature, grind size, and contact time determine extraction. Hot water dissolves about 30% of coffee solids. The first part extracted is bright acidity, followed by sweetness and finally bitter tannins. Similar to how wine pressing yields free-run juice first and more tannic press fractions later. The pleasures of coffee and wine are built on chemistry. Over 800 volatile compounds contribute to coffee aroma. Roasting triggers Maillard reactions and caramelization. Wine's bouquet evolves as esters, alcohols, and phenolics interact in the bottle. Both beverages balance acidity, sweetness, and bitterness. Even caffeine and tannins, though chemically distinct, share the ability to grip the tongue and influence perception. Coffee houses and vineyards have shaped societies. In Ethiopia and Yemen, coffee ceremonies honor the bean's origins. In Europe, cafes fueled intellectual movements. Wine rituals, crushing grapes by foot, aging in underground cellars, toasting, reflect culture and geography. Appreciating these beverages means appreciating their stories. The terroir of soil and climate, the skill of farmers and artisans, and the unseen labor of yeast and bacteria. From the first crack of roasting coffee to the last racking of wine, both drinks depend on fermentation and heat, patience and precision. The next time you sip a morning espresso or savor a glass of Cabernet, remember the pickers on steep hillsides, the fermenting vats humming with yeast, the roasters listening for cracks, and the winemakers topping off barrels. Each cup and glass is an alchemical fusion of nature, science, and culture.